Okay, I'm going live. Hey guys, it's Mike for Faraday Research. Welcome to the show. We're doing free open lines tonight. As you know, the live chat is now open. So if anybody wants to join, you can join the live chat. As you know, last 2 weeks I've been off sick. The whole family got hit with the flu, and haven't been online doing any shows for the last couple weeks. Hopefully we'll get some people to join in. I did put out the notification earlier, so hopefully we'll get a bit of an audience show up. But regardless, the show goes on. Live chat's open. If you want to join me, I also have the link for the show in the live chat, so you can check that out. You've got it posted on the screen. So if you want to join the show, it's open lines. You don't have to be a pro at it. You can just join the show and ask questions, throw ideas back and forth, and yeah, we'll see what comes of it. I have been doing a lot of work in the last week on the Renegade device. Did some more hardwiring of the return power to the charging system of the Renegade, which I'll probably show some video clips of that very soon. Live chat is open. I also have the StreamYard link if you want to join in and have a chat with me. We can do that. You don't have to be a pro at it. If you got a regular browser, you got a headset with a microphone, it's really, really easy. Mike, you just joined in. If you want to jump into the show, that's great. Yeah, I got lots to talk about. The Renegade device, what I've done with it, what I was able to do this week, which was totally unexpected. So, excuse me. Yeah, it was. I'm actually able to get the Renegade device to run without draining the battery to the point where there's basically a negative resistance in the circuit. I use the Adams motor type setup, the Adams motor device slash Bendini slash Joseph Newman. So it's kind of a mix of the three devices in one. So I was able to actually pull it off where I could run the device and not kill the battery. Now, that's pretty much what everybody's trying to achieve. So I'm going to go through some of that tonight. If you're just joining us, live chat's open. It's open lines tonight. If you want to have a conversation with me, all you need is a headset, microphone. The link is in the live chat there right at the top, StreamYard. And just click on that and you can enter into the backstage and I'll let you into the show. So yeah, let's get a conversation going. Any questions, comments, if you don't want to join in video wise, you can just post it in the live chat. So as I was saying before, the last 2 weeks I've been riddled with the flu. The whole family pretty much got it, so I wasn't able to do a show for the last couple of weeks. I think after tonight's show, I will not do a show until after Christmas because next weekend is the weekend of Christmas. So I'll probably hold off from doing a show there. Yeah, so I'm just going to go over some of the stuff I've been doing. If you want to check me out, I'm at Faraday Research. Faraday Research on YouTube, and I got all my videos there. I've got pushing almost 400 videos, which is actually pretty amazing. I've been able to accumulate so much videos on my site. I have almost 2,800 subscribers right now, so the web page or the YouTube channel is doing really good that way. Okay, let me just get into. Let's go to my channel here. If you're just joining me, there's the live chat open. I also have the link if you want to join in and have a conversation with me. Okay, let's go to my latest videos. We'll pull that up. All right. We're going to do share screen here. Share screen. For a second. Let's try this again. I'll get to your question in a second. How are you measuring the power in and out since it is pulsed? Well, see, that's the thing with these motors. It's very, very hard to actually get um, an actual like consistent power. So what you have to do is you have to dump that power into a capacitor and then feed off the power off a capacitor, because the capacitor, what it does, it basically cleans up the signal if it's pulsed. Usually what I try to do is put it through a full wave bridge rectifier first and put that through a set of capacitors and then take the voltage reading off the capacitors. If you do it straight a pulse, you're not going to get a consistent and a really good reading on it. So power in's a little different. You just take a regular voltmeter and you can measure the voltage of the potential going into the system, as well as hooking up a current meter on the input. So you know how much milliamps or microwatts. I'm actually in the picowatts of input of power. I'll explain that later. Let's go to my. Let's try it. Okay, let's try this one more time. See if we can get this to work right. There we go. Share. Let's try that. Let's try playing this. Hopefully the audio is going to go. Oh, the audio is not working on this. Alright, I'm going to have to stop that for a minute. I'm going to go to my settings here, see if I can get the freaking thing to work. Let's go audio. Let's go. Try that. Hopefully, sorry about this, guys. Sometimes it doesn't always want to work. Alright. Let's try this again. Hopefully Hopefully it's going to work. It's not working. Okay, I'm going to stop sharing the screen here. Great. Okay, we'll have to skip on that for now. Yeah, I don't know, Mike, are you available to come on? The link is at the top. So, let's go audio here. So anyways, what I was able to do is get the pulse motor to the point where it doesn't drain the battery, which is really, really important. Okay, we got Mike there. We'll add Mike to the stage. Mike, are you there?
You hear me?
Yeah, I hear you fine. Can you hear me okay?
Yeah.
Perfect.
Hold on
Cool.
a second.
Yeah, so it's been kind of a crazy 2 weeks. I had the flu, and family had the sick too. So last 2 weeks I wasn't able to do a live show. So I'm back. I'm better now. Been doing a lot of testing in the last week. So what have you been up to?
Just taking care of the house, working on the house, and
You were doing the roof, right?
yeah, been on that for a while.
You're in Florida, right?
Yep.
Yeah, how's
Nice
the
and
weather there?
it was good. It just I think this solar thing is causing a lot of
Yeah, there's supposed to
rain.
be well, there was a big X flare yesterday. Actually, it made the news, and all the AM radio band this morning when I was driving to work at 5:30 in the morning. I was all scrambled. I could hear all the interference. I thought it was power
Oh,
line.
really?
Yeah, oh yeah, because I live
Huh.
more north, right? I live more in the northern hemisphere, and usually if there is like a meteor shower or aurora or any kind of solar flare, it seems to hit the northern hemisphere pretty hard. So we didn't have a complete radio blackout, but we definitely had interference. So
Hold on, let me. I just made a quick drawing. I wanted to discuss with you.
I've got another person wanted to join here. We got Anthony. I'm going to add you to the show here. Anthony, how's it going?
All right, how you doing?
Good. Better. Not sick.
Hey, Anthony.
Yeah, it was a rough 2 weeks. Finally got better.
Hey, you look like you're in the dark.
I think, yeah, he is in the dark. Well, he's doing renos on his house.
I'll be right back.
Yeah, so yeah, I'm better now.
Mike.
Thank God it's not at Christmas, so hopefully I'll stay healthy through the Christmas. So we're going to be doing our show tonight, and then the next show will be after Christmas because next weekend is the weekend of Christmas. So yeah, I figure it's better that way. Everybody's busy doing their thing, right? Getting ready for Christmas, the last rush. So I've been kind of taking advantage of the last week since I've been healthier to do a lot of work on the Renegade device and get it to the point now where actually it's kind of a crazy turn of events. I was always using a spark gap switch in my motor. So I decided I don't know why, but I decided to hook up an SSR solid state relay as my trigger. And I got some very, very good results. So excuse me. So I was able to get the motor to the point where it ran it over 6 hours and the battery didn't drain. Excuse me.
Have you tried hooking it up to a large capacitor?
Yeah, I have a couple. I have one that's 80 volts. I think it's 12,000 microfarad. The big blue ones. I got those. Um, I hooked it up to a small capacitor banks, 12 volts, and it's 90 farad. And I was able to charge that up pretty quick. So I got the initial drive coil that runs the motor, and then I hooked up another big coil right behind it. So all the pulsing that the drive motor or drive coil does, that pickup coil is now picking up that flux. And that power, I rectify it and then I dump it right back into the battery. So basically, the motor is running on picowatts of power because it's not draining the battery. So after I shut, everything down, you know, come back the next day, the battery is basically where it was when I started. Monday night, I did a 4.5 hour run. The other night after that, I did a 2 hour run. And last night, I did another 2 hour run. And the battery's not dying, it's not going down.
Are you using a higher voltage with the thinner wire for the coils?
Well, the coil, I've stayed with for
I
some
was thinking that
reason.
might help instead of having diode losses.
Yeah, I've always stick with 24 gauge wire. That seems to
Okay.
be working the best for me. Now, I was thinking of the pickup coil. I could actually go to a thinner wire, say the 26 or 28 gauge.
No matter the gauge, you could always lower it.
Well, see, the lower gauge, I'll get less current, but I'll get a higher voltage. So if I go, say, down to an 18 gauge, I'll get
I'm
more
gonna
current, but
reconnect. I got
less.
an echo.
Um, I'll
That might have been me a minute ago.
Oh,
About the echo, that about a minute ago when I joined in, I forgot to turn off the YouTube audio.
Oh,
oh yeah.
that'll do it. Yeah.
Hey, you can no matter the gauge, even if you got a thick winding with low resistance, you can really shorten the duty cycle to control your current.
Well, the optimum duty cycle I'm running the motor at now is between 50 and 55.
It's all based on your controller, how fast you can turn on and off that switch.
Right, but that's not always the answer. I'm starting to find out if the duty cycle is a little bit lower, down to like 50 to 55 cycles per second.
Well, you know
I
what's
can actually,
the Adreno, you can pulse it a really short pulse, and you can give it a long wait time before the next pulse.
yeah, that's where you have the advantage with the Arduino. You can really dial in those
I found that interesting.
parameters. But irregardless, it's getting a very strong pulse, um, but it's taking no current to run it. It's like it's running off, basically
Yeah, you don't want to use any current.
So I'm finding the motors work better with uh, a higher voltage input, and the higher voltage input you put, it doesn't demand any current at all, especially if you get over, say, 36 volts. It requires like almost non-existent.
Yeah, that makes sense. Because you got enough pressure to get through that coil without any problem.
Right. I got another joiner here. I'm going to let him in, David. It's open lines tonight. Hi, David.
Hey,
Welcome to the show.
thank you.
Hey, dude.
Hey,
Hey,
so have you ever thought about building the Tesla turbine and all of the blades that make up the turbine, treating them as if they are Faraday discs, not using the turbine for its torque? If you build that with the magnetics set up appropriately, once you achieve a certain diameter,
Yeah.
you could have that on a closed loop system with a boiler and a condenser. You just want to cool the water down to where it's still hot but no longer steam. So it
Right.
takes very very little energy to make the hot water boil again. You just need it back in liquid form.
Yeah.
With
I don't
that
know if you.
setup,
sorry, I don't know if you've checked out my site. Actually built the Faraday disc. I made a miniature replica of the end machine, and I did that about almost 2 years ago. And I was able to generate out of 3-inch diameter. Uh, the fishing magnets, the really powerful ones that lift like 600 pounds. I
Yeah.
got two of those, north poles facing out, south poles facing in, with about a 1-inch gap between the two magnets. I was generating about 25 amps of
Have you
current.
have you tried putting the magnets attracting toward each other?
I haven't done that. I got my best results with magnets facing out. So north facing out, south facing in.
The reason you might want to make them in attraction, if the magnetic lines of force aren't 90 degrees to the face of the disk, you'll have losses. And them attracting toward each other will make it so your lines aren't like curving around. It'll make them go toward each other.
Now, there is a way of getting a lot more voltage potential out of the Faraday disk. And Peter Linderman and Aaron Murakami, they actually built a device that did that. So what they did is they basically sectioned off the segments around the magnet going around. So it's like spokes on a wheel. So because of that, they were able to cancel the lines of force in between those spokes and hook that up to a small. Actually, no, they hooked it up to an old um, Ford engine coil, and he was able to get about 100 volts out of it. So that was
Are you,
quite
you
interesting.
come out for that motor that they made that kind of looked like it went around like a Taurus? Is that the one you're talking about that they made?
No, no, no. He basically just tried to reinvent the end machine, but at a way
Oh,
smaller scale. Yeah.
yeah, I've seen a couple of different things he mentioned, but he never went into the details.
Yeah.
Where he
So
said he was getting more energy out of the power line, for example, or he was reusing the electrons' energy. He said,
yeah, see, like the original end machine that Bruce De Palma made didn't have uh, the magnets set up in segments like spokes on a wheel going around. It was just one solid mass, or sorry, two solid masses of
right?
magnets. So, but then again, his machine weighed 1,000 pounds.
Oh,
So you
did
got
it?
1,000 pounds worth of magnets, and you're spinning it at 10 to 15,000 RPM. He was getting 80 volts at 2,500 amps. So he was getting a
What
bunch
he
of power.
should sorry.
Go ahead, David.
What he, what he should have done is just blasted the schematics wide open and free to the internet, not worried about patents. Just, you
Well,
know,
ultimately, in the end, he buggered off to where was it, Netherlands, or what was it? I think it was Netherlands he took off to because he was getting so much flack. And Adam Trump got in trouble with the government. They seized his machine and threatened to prosecute him.
Oh,
And
seriously?
it was
Are you
yeah,
probably
it was
talking
a
about De
shit.
Palma?
Uh, uh, Adam Trombley was the only guy that kind of replicated what Bruce Obama did,
Hmm.
and he presented it in Washington. And after he did that, um, he was
That
getting a lot of flack. He was getting everybody was going after him.
that was like
So,
super low voltage but high amperage on the circumference of the
well,
disc, right?
Bruce De Palma's machines like that, but he was able to get it up to 80 volts because his machine was very large, right? So, as
Oh,
far
okay.
as I understood,
More diameter.
yeah, the larger the diameter, the more
Huh.
voltage potential you'll create. But
and the
number
voltage
one,
squares it.
yeah, exactly.
Yeah.
Squares the amps?
So I know they did a really large Faraday disc. I think it was at the University of Texas, I believe, back in the 50s. And the diameter of the wheel was something like 9 feet. The thing
Damn.
was ginormous.
You
The
couldn't just
thing was
take
just massive.
smaller diameters and multiple them up into series to get. No.
Not when it comes to the current potential, no. Like you could get a lot of current with a small wheel, but the problem
No
there,
relays could handle that or
it,
whatever.
no,
Brushes.
oh God, no.
You're
You know,
you
Bruce
could
would get, go ahead.
logically you could set multiple small Faraday discs up in series in parallel, but you would not be benefiting much from the squaring on itself effect.
Yeah. Yeah,
I've
it's
seen
not an
some
easy
places where
machine.
I've seen some places where they were talking about using those on submarines, but
Yeah,
no idea why.
well, they were using them back in the early days, back in the early 1900s. They were using them for welding because they were able to generate a huge amount of current for arc welders.
Well,
So they,
well, the ones
so they
I've seen were like in the 1980s. That
oh
was
yeah,
calling for projects that was like 50,000 amp output.
mm, I'm
I was
sure there
wondering
were
what.
people working on it. Yeah, there was a
Yeah,
guy
it's
in
like what on earth are they
there
using
was
it for?
another guy, Tawari. He's out in India. He also replicated Bruce's machine, and the government shut him down too. So
That's the Indian guy that
yeah,
was a
yeah, Tawari.
nuclear engineer or something like that.
Yeah, yeah.
When
He's
when
go ahead.
when when I have the time and resources to get something made, they won't be shutting me down. They're going to be shutting the internet down, and that they can't shut down.
Yeah, it will go like blockchain. It'll be like
I don't know. There's already several bills where they already put in kill switches.
yeah. I don't think it's
Censoring now is nuts.
you know the technology is going faster than what they can do to try to suppress it. You know they'll have
Uh,
blockchain stuff. They'll have
I say put it out a few different places all at the same time.
Another idea I had, instead of using a boiler and a condenser to take most of the heat away so it liquefies, an HHO torch, if you take that flame and put it on a glass of water, it won't make that water heat up.
That's
So
right.
what if you was
Really?
to do an electrolyzer and make two turbines, one that you're pumping hydrogen through and the other one that you're pumping oxygen through,
Right.
so it gets them spinning, and make sure you've got your volumetrics and everything equalized
Yeah,
to
that's
where
got to be done correctly. So you really got to know what you're doing with that. You mix hydrogen and
Sounds like an
oxygen
excellent
together.
rocket fuel.
Excellent
Yeah.
bomb,
yeah,
right?
yeah.
So you
Ec-
really
If
got
it
to know.
if it doesn't heat up and it's no wobbling or anything,
You'd think it turned
moving,
right to water, but you never know.
but that
Yeah,
would be another way you could get your pressure and suction on the pressure, turning the gases back into water
right.
in
Well,
in the same tank that you're splitting it from.
yeah. Well, see, another thing that's kind of making a comeback, and some engineers in the UK, especially, are taking a second look at is the heat engine, uh, like the Stirling engines. So there's a few people out there working on it, and they're getting some pretty amazing efficiencies, far surpassing what an internal combustion engine. They have one right now, I believe, is hitting about 93% efficient, which is actually quite incredible for a heat engine. That's not easy to do. So, yeah, there are several
It's all on the
technologies out there.
diaphragms with that engine.
Another one is the flywheel generator. You know, building these giant silos with these, rotating masses, and basically a zeroed
A Stirling engine
back.
powering a flywheel is a great.
Sure, exactly. Yep.
And while you're at it, you might as well turn that flywheel into a Faraday disc.
What people don't know about the Stirling engine, though, in general, most people don't realize that you don't have to generate heat. All you have to do
Is
is
a temperature differential. Yep.
put half of the engine in the ground, the half
Yep.
of the heat sink under the ground, and the other half of the heat sink above the ground. There you go.
Yep.
It's going if it's big enough, it will spin on its own,
Right.
and at that point you don't need RPMs at any higher rate.
Yeah.
You
With
just
the Stirling
you have the
engine,
torque going on already.
it's the temperature differential The
Right.
greater the
Mhm.
differential between the two, the stronger the motor
And
becomes.
look at the LHC, you know, that's a huge, could have been a Stirling engine.
You know,
All that
something I was
effort.
always wondering. Something I was always wondering with the Faraday disc is, forget the magnets, but just rotate at a high RPM. And at what point is the electron drift going to start causing a current flow to the outside? Especially if you like coat it with something like magnesium that's, puts out electrons anyway.
Yeah.
Something on that. All right,
Hmm.
two things I want to mention. On what you just said, I have wondered if you can align the
From the
disc,
centrifugal force, but go
if
ahead.
it, in regards to the way the magnetic lines of force coming from the north, in regards to the way they're flowing, if you could orient your disc so the lines of force from the north pole or, center, whatever, um, if you could make your disc 90 degrees to the direction of them lines, couldn't you use the magnetism of Earth? But you'd probably have to get it like perfectly spot on. I don't know how strong it would be,
You would have to
but
be on a ley line to achieve something like that. If you're on a ley line, that's going to be the greatest advantage. I found out this week. Uh, there are some nights I'll try to turn my motor on and it won't work at all. It turns out I supposedly live in the worst possible place. I live right beside a railroad track, and that apparently destroys the electromagnetic field of the ley lines that's close to where I live. So I'm like, oh man, really? I'm like, because
That makes
there's some
sense.
nights, some nights it kills my motor. It won't work. It won't even turn on. So
something else. I don't know if this will work, but for an electric vehicle, your axle, if it's made out of iron, and you can magnetize your axle appropriately, it's going to put out very little volts and high amps because of its shape. But what if you could
Right.
turn your
That's
your
true. That's a
axle
good idea.
your your axle for an electric vehicle, turn them into Faraday discs?
It's so cool. Yeah.
that's
Why
a
don't we
neat
think of
idea.
this stuff? It's so obvious too.
Yeah,
Yeah.
it's amazing how you can apply this to certain devices that we already have.
But it's low voltage, high amperage. You know, you can take that low voltage and right at the
And that's what
wheel
the
and put it into a motor that's attached to that wheel.
that's what the
Since it's low
batteries.
voltage, you don't have to worry about
Yeah, the batteries are
traveling the current will get there. It's the motor's right there. You know.
the batteries are set up with 12 or 24 volts anyway, right? And higher amps. So run it through a circuit or something and keep your batteries charged. Wouldn't that be something if you was to magnetize your axles appropriately and turn them into generators, aka Faraday discs, while you're
Yeah,
driving, and literally could travel to the ends of the earth and never have to stop
well,
outside of
that would
So
Has
actually
that,
you're,
has
work.
anybody ever
you're
has
drawing power
anybody
off
ever
the
done
gasoline
the
engine, though.
I mean, once you get to the ocean, you got to turn around, but
has anybody ever compared the three-phase generator to the Palma output comparison? Is it the same?
it's De Palma is DC, just
Yeah,
one.
DC.
yeah.
Right, okay.
It can
So
only
you have
be
a benefit
DC.
of being DC.
It can't be AC. The AC would create magnetic cogging, but with the you could make a disc that'll put out AC,
Right, that's correct.
but
DC will not have that cog because you don't have
yes, you're
you don't have the negative. It's only positive.
So if you
you're
have,
you're
There's
you're
no sound.
I've,
benefiting
I've, seen,
you're
I've seen a
benefiting
patent
from not having
version
the
that was
magnetic
DC.
cogging.
There's a patent out there. I wish I could find it again, but instead of using the normal, coils with north and south on one side, it in different coils, it just had um, almost circular path of one coil all the way around it with a small gap at the stop. and it just had one magnet with the north against that coil that would sweep across it. So you'd get, maybe, 95% DC and then a pulse with no power, and then, 95%, DC 95% of the time again. I can't remember what the patent was called, but it was an interesting idea at least. Oh, for the motor, have you seen the Flynn patents? FLYNN.
The name
He
rings a
uses
bell.
flux switching. I thought that would be an
Rings a
interesting
bell.
idea for the pulse motor. Yeah, there's what is it?
The name is familiar.
Flux switching.
Sounds familiar.
FLYNN.
So what you're
But
saying
for
in
the-
AC, what causes the cogging is the
You're
top and the
switching
bottom of the sine wave. It's
switching
causing
switching back and forth between north and
positive
south.
and negative.
Yeah, you're
Right.
that it'd be the same as just flipping the magnet around, but
Right.
going between the different fields is
So
going to
when you say
create
cogging, that's not the same thing as the magnet.
Well, this
resistance.
way for flux switching.
the iron, it breaks, but that's not what you're calling cogging.
like if
Right, well,
you
this one doesn't have it in the first place, just by design.
Yeah, but like a magnet on a wheel comes through the iron, and the iron breaks your wheel.
like
because it's sticking,
have-
right?
have
That's not the cog. That's not the same thing. That's just
have you
breaking force.
have you seen
But-
how
The same thing
there's a
happens
vid-
with AC because you're changing the pole back and forth.
there's a video out there on one of these science channels. There's a
Put the link
big
in the
slab.
chat.
There's a big slab of copper on a table, and they have a much smaller table with 3 or 4 legs, and it's spinning blocks of woods, and on that block of wood it's got north south alternating, and each one of them, they spin up and the table levitates. Have you seen that?
Yeah, I've seen that. Yeah,
And
that one.
and
that's
And
from
the
other
cop-
current.
yes, the copper gets very hot.
Yeah.
It'll be the
Oh,
same
you mean where it's below?
it'll be the same type of effect. That is essentially magnetic cogging.
Yeah,
I've seen
It-
where the
The
old
copper is
demonstration-
absorbing the electrons,
It wasn't moving;
But
it
it-
was just wheels.
But if they just
building
had
up
on,
vibrational.
but if they only
radiance,
had
radiation.
just one magnet and the pole staying stationary and spinning it, it would never levitate. But the same kind of principles, the way that was able to levitate,
So by the
is-
push and pulling, you're creating the friction.
yeah. But with it just
just pushing or just pulling,
with
you
just
remove
one
this friction. Because
With ju-
essentially
with-
when you put a north there and then a south right in front of it, you're essentially canceling.
with the
your own
magnet
field.
and with the magnet and the disc the same size spinning over top of each other, you're not passing through and you're not flipping the pole. There's no magnetic resistance that you have to fight.
Right. Yeah, makes sense. I
And
didn't think
that's
of it
what
that
you-
way.
That's one
But
thing
it's
that you
still,
want
even though with a DC monopole pulse motor, you still have that braking force of the iron and the magnet.
see this
That's not the
doesn't
same
have,
thing though.
Yeah,
That
you're
reminds me how
doesn't
some of
have-
the trains work.
this doesn't have
You see
any
the
braking force.
the trains that levitate, that induct track thing.
Yeah.
I put the
Yeah.
link up for it. That's reminds me of how that works.
Right. The
It's got the
Palma
same,
device is all copper. There's no magnet.
Oh, they don't even show a picture in these. I messed up.
DC.
I thought they'd have a good picture of it, but yeah, they leave a good picture in it. So,
But that's an easy way to do it. If you want over Unity, put a boiler and a condenser and a Tesla turbine in a closed circuit and have your magnetism appropriately aligned for each disk, and tap each disk individually and don't use the turbine for its torque. Once you achieve a certain diameter on that, you're going to have, even after converting the high voltage into amperage to run your boiler and your condenser. Even after those losses, you can achieve a certain diameter and have more output than the system consumes, and it'll just keep going. That's one answer how to achieve free energy.
There's many ways.
I think that
And
Flynn and the
The Palmer device sounds like something you would take that low voltage, high amperage right away and convert it right away
Yeah,
to
like
such a low voltage.
they built a giant rig. It was kind of looked like a computer rack and a whole bunch of cabling, and they were using that as the resistance basically, and they were just pumping the amperage right into that. They were starting to heat up quite a bit.
who was
So
that?
Brewster
They're
Palmer,
just creating a shunt.
yeah, a shunt basically, yeah.
hey, what do you know about the
Dump load.
Sorry,
The
say that again.
Starship? What do you know
Oh,
about the Starship coil?
I've never really played with it, so I can't really comment too much on it.
I seen somebody. You can find the video if you look. Starship coil magnetic field demonstration or something like that. They're using a magnetic viewing film, and they put it over top of a regular magnet, just showing that you'll see a dark circle the same size as a magnet. And as you lift the magnetic viewing film away, the circle gets a lighter color
Yeah.
and bigger because the lines of force want to curve out, kind of like butterfly wings.
Hmm.
But a starship coil, when he put it over top of it, sure, it wasn't a perfect circle and you could see lines and stuff in it. But as he raised and lowered it, it didn't spread out. So the starship coil confines the magnetism more like a beam and
Yeah.
doesn't allow it to
Hmm.
shortcut
Yeah.
around the outside of the coil. It confines it all. And if you have
Oh,
AC
David, you really got
or
you really locked in on some of these devices pretty well
yeah,
there.
if
we
if
we were
you
familiar with all of them, but you
square wave
really
would be
fine tuned it there.
square
I
wave
didn't
would
know
be
that.
best to run through a starship coil, but if you run AC or square wave through a starship coil, anything ferrous or magnetic inside will spin. So sure you could the city towns and all this, sure it'd be a lot metal, like solid metal instead of coils, but there'd be less that could go wrong with it. You could use the high voltage from the power lines. So wherever you want a transformer, have a starship coil and a big slab of copper, and that would get that copper spinning. And you could literally tap the disc at different points to choose how much voltage and amperage you want to take off of it. Like, don't bring your disc all the way to the dead center, or not your disc, don't bring one wire all the way to the dead center and the other wire all the way to the outer edge. Vary them, not quite to the outer edge and not quite to the center, and you can manipulate your voltage and amperage output. So you could turn that disc into a transformer like that. So if there was ever a power outage, it wouldn't be an instant blackout. It would be a slow brownout because that Faraday disc, that big flywheel, it's already got energy stored up. And
It's spinning.
taking energy off of it doesn't slow it down. Whether
Yeah.
you're outside of the friction of your wires, outside of that, taking energy off of it or versus not taking energy off, it doesn't make it slow down any faster. So it'd be like a slow brownout instead of a blackout if they were to
Yeah.
do that.
Yeah, it would give it some redundancy if there's a power failure, right? Because you got a
Yeah.
spinning mass there, and if you
Yep.
got the Faraday disc spinning as well, yeah, it would be a very good backup safety system if you got, say, you're running a system that is critical and has to have power, right?
So they could make all the transformers that kind of setup.
Sounds like storing energy in a superconducting coil.
Well, it's either
Some of
Not
the ideas
superconducting
for that.
coil, but the way my
that would
motor works is like kind of like a tank circuit, right? And
Giant
the battery
inductor.
and the battery is part of that tank circuit. There's a couple video. Dan Winters did an interview about a year ago. I have it posted on my community section on my Faraday Research YouTube channel. If you go to that my channel, click on community. I think it's the second link below. You'll see Dan Winters. Watch that video. It has really good insights on what people refer to as 0 point energy, and it explains very, very well what it is and how to use it, and some of the devices that were made that are actually real. So, yeah, like I've kind of dabbled in a lot of things over the last 5 years, but I've really focused on the pulse motors for the last couple of years. So, yeah, the Faraday disc, I worked on that for about 6 months, and because I wasn't at that time wasn't able to get more voltage out of it.
Voltage, right?
Yeah, I was able to get a lot of current. I was generating.
What were you getting? 2 volts?
No, not even. I was getting point. It was 90 millivolts at 25 amps.
Well, how big was the disc diameter?
3-inch diameter.
3-inch.
How thick? How thick was it?
They were about half-inch thick magnets. Yeah.
What did you use for the disc?
Well,
Did it matter if it
on
spun
magnets.
vertical or horizontal, or was it the same?
You know,
Well, I had it spinning this way, right? Horizontally. But I was using magnets, so you can get the same effect just by spinning a magnet, not just
Yeah.
You got
Your-
the Faraday
You're right. That's
paradox,
true.
right?
That's true. Right.
The Faraday
A
Your
paradox.
homopolar motor.
your magnet and your disc can be the same material, and it's irrelevant if you have 2 discs, one metal disc and one a magnet. It is irrelevant if the magnet spins with it, against it, or sits still. It doesn't
That's
matter.
right. It's called the Faraday paradox,
Crazy.
and you can read up.
That just really messes with your head.
It does.
It
The
sure
Faraday
does.
The Faraday
What,
paradox.
did you just say what I think you said? You're saying if the magnet and the copper are spinning in opposite directions, it makes no difference if they're
Yeah,
not
correct.
doing that and
Yeah.
spinning together as well?
Yeah, exactly.
Correct.
That's the Faraday paradox. If they spin together at the same
It's like
time,
something to do with the mass and nothing to do with the materials.
I think it's the permanent lines of force from the Earth's magnetic field that's helping that.
And you can't, like, just say you've got like an LED and you hold it up to the disc, and while it's spinning, your contacts are scraping the disc, and the LED lights up. If you solder the LED to the disc so the LED is spinning around with it, the LED won't light up. So you have to have brushed connections.
Yeah, so I had really good brush connections on mine, and they would just sit on the leading edge. And I spun it up to about 1200 RPM, and I was getting about 25 amps. And I was using an analog.
I was wondering. Oh, sorry.
Where'd you
I
get
was
the
wondering
disc?
if you.
No, they were magnets. They were fishing magnets, the 3-inch diameter fishing magnets. That's what I was using. I was spinning those.
Fishing magnet.
Where'd you get the disc from?
What's that?
Where did you get the metal disc in the first place?
No, there is no metal disc. It's magnets only. Magnets only.
Yeah,
That's all
it
I
doesn't
know.
matter if it's
Hey, what
copper
I
or a
see
magnet.
was 2 magnets on
So the ceramic on the inside of a magnet, that what they're made out of, are they electrically conductive? If you take off the
this one
coating.
the one I had zinc coating, so they were conductive. Although,
But if you take off the coating, is the inside conductive?
no, it
a,
isn't.
it's an insulator.
So you
Yeah, no, the
were
ceramic ones
benefited.
are insulated.
Same for the Neos. I've tried it.
So
the
you were
Neos are like rubber on the inside. They look like rubber instead of metal.
so that would mean that you were literally just using the coating on the magnet, and that's why, because that coating is so. Wait, but you said
If
you
the
had
coating's
higher
an
amperage.
insulator,
It's not an insulator. It was zinc. So there was.
Well,
semiconductor.
terrible conductor.
It
At least
was
the ones I
conductive.
So it had some kind of conductivity to it, not much.
Yeah.
That would act like
You
a
took all the
relay.
time with the coatings, right?
But the thing was, the second I started spinning the wheel, it was instantaneous current. Like it was right there. It was on. And there is no resistance in that motor. So if you put a load on it, the motor does, or the magnets don't slow down. There's no cogging of the wheel, nothing of the sort. That's the advantage of that.
No back EM drive effect?
Nope.
That's zero. There's no effect on the wheel. So you can pull 25 amps off that wheel. The wheel doesn't notice it. It just keeps going. There's no resistance.
That is
Even if you were to
unique.
dead short it, it'll just keep going. You get dead
It's
short.
because there's only one pole. It's like a monopole.
Doesn't slow down at all.
Hey, your rims on your car, they're made out of iron. So what if you could appropriately magnetize your rims and turn them into Faraday
Right.
I was thinking,
discs,
the
But-
disc brakes myself.
but have it set up where it's kind of like a cylinder
Now
style?
use what?
and-
Use the brakes as your
Faraday disc.
as your brush.
Yeah, well, they would have to be conductive. You could use regular.
I mean, you would probably use that system that you're describing, David, as regenerative, an alternative to what they do for regenerative braking now.
Well, see,
Yeah.
Bruce De Palma.
And when you hit the brakes, the brake pads, it could just be at the same time. The brake pads could double as your.
Yeah,
as your trigger.
The best method for picking up the voltage off the Faraday disc is using mercury, and that's what Bruce De Palma. He created a channel along the leading edge of the wheel, and it was like a channel, and at the top of it was a little jar, and he would fill it up with mercury, and the mercury would actually be the contact point, which is kind of toxic, but it makes the best brush for shit like that.
Something I was wondering, I was thinking the Tesla turbine, when you build it, if you was to have at the very bottom of the drum, just, have like just a little line of mercury going across, would there be a certain speed at where it would just spread it way too thin or fling it around way too much to where you wouldn't have good
You'd
electrical
have to
contact?
create a channel. It would have to be like a channel going around the disc, and it would have to be very close tolerance, and it would work. It would definitely.
I'll show you what I thought of a way for a solution for that. If you can see it, have the edge with the little. See the
Right. Yeah.
Are you
like
What are you using the
it
mercury
won't have the
for?
contact in that,
The
so the
contact,
centrifugal
your-
force
your
won't
contact?
throw out the mercury, but it
Or
will
the
pull. It will stay
brushes?
pulled there.
I think I think I just had the thought of what you were just describing. So along your disc, have like your drill bit over top of the center toward the edge. Like, hold on a second.
Yeah.
Well, it's like here. The
Like-
centrifugal force would hold it in the edge instead of throw it out.
So like if
See,
this is your disc, cut and your disc is thick enough, cut a channel in
Yes.
and
Right,
put enough mercury, so as it's spinning, you literally have an outside wire coming up and over and hanging in like
Right,
that.
Right.
What's
Yep.
the why the mercury? Just for making
It's the best
contact or
contact.
something?
Yeah, it's the best contact brush and zero.
So-
almost zero.
Oh, for replacing the brush. Okay.
Yeah. and
Well,
it doesn't
instead of
wear out.
wearing away the metal,
Right. It'll
It'd
last
be
forever.
a friction. It'd be a frictionless.
Yes.
well,
liquid
what might be better is like, what is it? Somebody made a mixture of gadolinium and something else. Gadolinium will usually eat
Why not
metal.
a spark
But-
gap? Why not
but
a
they-
spark gap? Why mercury?
You could do that too.
What's wrong
You
with a
can do
spark
that
gap?
too.
I mean,
But
come on,
either way,
man.
But check this out. Somebody made
This
this.
exotic stuff can get dangerous.
Somebody made this. I can't think what it's called, but it's for your CPU heat sink, but it's liquid metal instead. But
Arctic
originally
silver.
gadolinium would eat away at it, but they've made a compound that won't eat away. At least that's what they say after a few years. And
Arctic
you
silver?
know, something that's not so
I mean-
toxic like mercury. You know,
Right. You mean for a brush or a spark gap or whatever?
yeah, for the little gap there with the metal.
I've thought of a
You
spark
could
gap,
make a spark
but
gap
that's
that
going.
would last forever. I mean, just 2 pieces of thick iron. I mean, how long? I mean, that's
But
going to take a
a
long
s-
time to go bad.
do you know
Well, if you
how
had a lot of current going through it, that would eat away pretty fast.
do you know how
Really?
EDM
What if there were
machine
two
works?
Bolche balls, of iron?
Do you know how
Well,
EDM, Echo
Yeah,
Delta,
yeah,
Mike?
well, that's
works?
what I'm thinking. The NDM effect would eat away at it.
Yeah.
Even at low voltage?
Yeah,
If you got a plasma arc period, over time it's going to be eating away at it.
Really? I
even
was
if
under
it's
the
like,
delusion that you can go with, a bigger piece of metal and lower voltage and not have that problem.
No,
well, that'll make it
eventually
last
it'll eat away.
longer, but it'll still eat away at it.
Hmm.
Even I see the thing where just
Yeah,
putting two
well,
different
it'll
films of
take
metal
what, a couple
together.
100 years to eat away at that.
Yeah, well, no, it'll do it in like weeks at the most. I see the thing just where they were talking about using like some of
Even
the electrical
silver
wiring
coated
now.
and all that.
Well, some of the electrical wiring now is now
What
aluminum
about
instead of
gold
copper.
coating? Gold plated.
That would help, but it would still do it.
To
you
eat away
lose
at that
the
too?
coating. But just mixing the metal itself, you got to be careful of that because it's like mixing aluminum and copper wire, and you start running power through it. That starts working like electrolysis and starts
Creating all
eating
kinds
away
of
the
crazy
copper.
rays and
For
stuff.
some reason, it eats away the copper, but not the aluminum. I don't know what it says. That it did it when I looked it up.
There's another machine you guys might want to look up. See, Bruce De Palma basically copied.
So that's where
the work
transistors
in the
come
valley.
in,
They copied the machine called the Sunburst. That was the original machine. It was made in the valley in San Francisco.
Oh, right,
Bruce De
yeah.
Palma, yeah. So you might want to look up that machine. It's called the Sunburst.
I'd like to know what he was talking about when. I can't remember if it's the same guy, but it was right about the same time where they were making a machine like that. But they said they made a solid state version of it. But as far as I know, he never told anybody how it worked.
I think it was Adam Trompley you might be talking about.
I think you're right. I couldn't remember the name, but I think you're right.
Yeah, he took a lot of flack for that. Yeah, he had a lot of problems. So he kind of went underground, and he hasn't really done that much since that. They must have really put him through the grinder, because I haven't really heard much from him since. So that was early 90s. So,
Is that me? Was somebody else talking first?
Not me.
oh,
I don't think it's me, but
probably hear.
I don't have anybody else here. But
Mike,
I
you
was-
see that? Can you bring up that schematic there? I want to ask you something.
Yep.
Ask you guys something. What do you think about that? That's
Any of y'all plan on building an HHO generator?
I've done it.
I'd like
I
to.
still got plans on doing something like that.
I'd like to do it, especially for the torch.
I think I have a
I
design
like the fact that
idea.
you can make cooking gas out of it.
I seen it was supposed to be good for pain too. Somebody had one of the pages mentioned where they put that on their back because they had a lot of back pain, and it said
Hydrogen.
within a
It's-
few
it's-
seconds it got rid of the pain.
It's
So maybe
the
it'll help
hydrogen.
healing somehow.
Hydrogen does miracles for your health. Look up hydrogen for health.
Yeah.
Okay, yeah, I hadn't heard of that one.
Well, you
I've
put
heard
that
of like pulsed EM,
Yeah,
pulsed EMF, but not hydrogen. That's a new
Yeah,
one.
you put hydrogen in the structured water. I do structured water. If you add hydrogen to it, it makes it that much better.
If you get the hydrogen 4% or less by volume, it's 4 point something, but forget the decimal, go under that. 4% or less by volume, it won't be able to ignite, making it safe to inhale.
Yeah. So
4 the hydrogen. You mean 4?
It's at
4%.
it's 4 point something where it'll be able to ignite. 1 point below that, it won't be able to ignite.
You mean it's
So just-
4% pure hydrogen?
Just your flow rate, mixing with
Oh,
take
With
a
water.
certain amount of just regular air and a certain amount of hydrogen and just mix them through one tube like a cannula. As long as it's by volume at any given
Here.
moment, 4% or less, it's not going to be able
Ignite.
to ignite.
I was
So
on a
5%
WebMD
is a
too,
good-
surprisingly.
I have George Wiseman's machine, the Hydrogen for Health. But if you use graphite instead of stainless steel and run practically no amperage, like extremely or not, extremely small amperage, like 0.00 whatever, extremely small, and really insanely high voltage, like 20,000 plus volts, you will get a higher flow rate of gas per wattage. If you build two setups, make them identical as possible, your same volume of water, same volume of electrolyte, your graphite versus stainless steel, keep the measurements the exact same amount of surface area, and keep the wattage the same per both scenarios, but one of them's practically no amperage and insanely high voltage, and the other one's just like 1.2 volts and high amperage, but the
No,
wattage between them are the same.
this
The graphite setup is going to be more efficient, and it'll keep the water cleaner.
Yeah, I'm just gonna
this
scoot
is
away
out of
for
the
2
box
minutes.
thinking right here.
I'm gonna scoot away for 2 minutes. I'll be right back, guys. Just carry on.
Is that a
A-
discharge tube next to the NPN transistor?
Say again?
Is that a discharge tube next to the NPN transistor?
No, that's the neon bulb. That's just in case you don't
Okay,
blow
well,
out your
same thing, yeah.
transistor. I don't know. I guess you calling it a discharge tube, the H.
Yeah,
high voltage neon bulb?
usually the discharge tubes are like neon bulbs, but they're made for higher power. It's basically a spark gap in gas to
Yeah.
protective
It
device.
protects your transistor.
Yeah,
I added
Same
those
idea.
two diodes there, and that extra coil on the red side. That's the
Oh,
inductor
is this
that
your
gets
schematic?
charged. It's the Bedini
Oh,
circuit.
okay. Okay, right.
I had an idea come to me once. You know how like a fork winding up spaghetti, like if you got your cable and you just start coiling up the center, how the ends will come to the center. If you start on one end and don't let your finger off of it and trace it, you'll be making a clockwise path. And then once you get through the center, as you work back out, you'll be making a counterclockwise path. So you can use if you use that, and I didn't know what the name of it was called. I found somebody online finally described it. It was called a B as in Bravo, bucking coil.
Yeah, the
And
bucking coil. Yeah. Hmm.
if you have a wall of material that has
Anthony, you don't
height,
know the bucking coil? You never
if
seen
you
a
have
bucking coil set up?
if you could take some graphite,
That's the version I heard of it. Just a regular coil that for the back EMF. So this must be something different.
if you could
It's
take a block of graphite and CNC into it, so you have a wall of material, not just a wire. Do that with graphite and make the bucking coil shape into it, and put insanely high voltage into it, and make the square wave on the voltage match the resonant frequency of the system. That would be an
David.
extremely
Let
efficient
me
setup.
let me describe the bucking coil to Anthony. It's just
All
a
right.
coil. You split it in the middle. One coil, right? One winding. You split it in the middle. You flip one half around.
Okay, I think I
In
found
the
what you're
center.
talking about. Like this, like this.
Right. Yeah. Okay. You flip one half around, so it's spinning the other way. And in the center, you have the north and south smacking each other.
But look at it as a pancake coil, though. That setup's a bit
They're
different.
bucking. The north and south are bucking each other. Bucking into each other.
So, in regards to electricity, when you've
I don't
got
know
that
exactly what that's supposed to do. How you siphon off of that? But it
you
definitely.
you've
The,
got the coil. The electricity is only going to go one way through that coil. So, if you was to like just look at it from the outer and work your way in to the radius, essentially, in regards to electricity, it would be like positive, negative, positive, negative, positive, negative, positive, negative, all the way throughout it in regards to electricity flow.
Right, at the start of the winding, you have a positive, and the next stop in the center, you have a negative, and then the next stop, you have a positive, and then the outside point, you have a
Yep. If
negative,
you
a
just
positive. Yeah.
Yeah, if you just run
So,
your
and
finger
and the
down,
poles are hitting each other,
so
right?
it would do electrolysis that way. And if you match the resonant frequency, I think that would kick out a lot of gas with very little energy. And you can replace chemical electrolyte with magnetism. A million and one ways to build an electrolysis cell. Doesn't matter how it's built. If you bring a strong magnet up to the plates that are splitting the water and just set it still, you ain't got to spin it, rotate it, pass it by. Just set it perfectly still. That cell will draw more amperage as long as it can handle the amperage. It will make it draw more amperage, and you'll get a higher flow rate of gas. So if you want a setup that doesn't use chemical electrolyte, this could be a potential starting point because your electrode, but it's all one, is in the heart of the magnetic field. You can't get any closer. So you might be able to split water without any electrolyte in your water with that setup. Might.
Isn't the
Or you'll
bucking coil the same kind of thing the Newman coil is?
I don't know of the Newman coil.
The Newman motor. It's the same kind of thing. In the center, you
Newman
start the
rings.
magnet on the shaft in the center of the coil. You take one coil winding and you stretch the middle out, so you have a gap there. And the two, you have two coils, and you just
Yeah, it's kind of the opposite.
you
Yeah,
flip the
instead of
one, you flip the
splitting the
other
coil,
half
you're splitting
around,
the magnet on the
and
same
it goes the
coil.
other
So,
way.
yeah, I see what you mean.
Yeah, one winding though, and in the center you put your shaft with a magnet, and that's how Newman drives.
No,
It's
But
a bucking
with
coil.
well, the only difference there is for Newman, since it's you've got this here, but you've got your magnet on both sides. But since
Oh,
you're
I'm
actually,
sorry. I'm sorry. The
one
bucking
direction
coil
is
is
here, one
pushing the
direction is
north and the
here,
north
you're actually
together.
adding.
I correct myself. I believe
no,
I had it
that's
wrong.
that's
Depends on which way you spin
that's
it too. The way I've seen it, it was spinning it was
The Newman is
the
the other
magnet
way
was this
around.
way, the coil was this way,
Same
but the
same.
magnet was vertically. So
that would be
yeah.
one setup for the HHO cell. But unless you're going to wrap foil and involve spacers, it'd be ideal to start with one solid mass and just cut your gap into it. That way it's more durable and you don't need spacers. But another setup I thought of, start with your primary, the Starship coil, and have your ferrous rod that's going to be the core for the transformer. Your secondaries, size them up to where the hole in the center of the Starship coil will perfectly match the diameter of your ferrous rod for the core. Ideally, you might want a high frequency one. So that's perfectly snug around that. And then whatever the diameter is of the points of the Starship coil, find a graphite sleeve, like a hollowed out rod, where it all perfectly sandwiches together. But the rod won't come all the way to the center. Have like a glass or a plastic spacer. And the end of the
Mm.
wire on one end connects to that particular rod. As you go down, then you got your glass spacer, and then the rest of the rod, and the wire on the other end of the coil connects to that one. So you want that spacer far enough so the electricity isn't promoted to go this way, and then fill that with resin so it all solidifies. Probably put like a bumped top or a concaved top. And when you stack them up hexagonally in regards to rows, make all of them wrap the same way. And the next row, flip them over so they're wrapping the other way. So at any given point, you've got a row of positive up top, row of negative up top, row of positive up top, row of negative up top. And between that space where it's not one continuous rod of graphite, the bottoms will be polar opposite, and at the tops are polar opposite, and you can have them close enough. And since a sphere makes the least physical amount of contact, you could probably do away with bearings and have something that sandwiches it together, match the contour of it, and your e- each all right
Sounds like you got to
multiple
draw this out, man.
multiple rods inside of your secondary. So your everything will be completely isolated. You're not bringing power from a primary and then a secondary and all of your electrodes in the center. You're not taking electricity like wires, bringing them around to each one, and then from the bottom to each one. You don't. It would be producing the electricity from the secondary inside of your electrode surface area. So it would eliminate the wires and eliminate the friction. And with a Starship coil, if you just got a piece of metal and you're running pulse DC or AC, it won't initially spin. You'd have to give it just a little bit of motion and then it'll take off spinning. But since there are Starship coils, multiple of them as secondaries stacked inside of one big primary, they'll automatically repel each other. So you don't got to give them that little nudge. And making each one where they don't spin as a collective, where they spin independently in place, that'll fling off the tiny little bubbles that aren't light enough to float up to the top. That'll fling them off, so you'll have more water contact in your electrode surface area at all given times. And if you set it up for Brown's gas, that'll be a lot of water disturbance that would also help release the Brown's gas. I think that would be the ultimate setup. You can't
What do we
get
do?
any.
What is this Brown's gas again? This is just like HHO, right?
It's
Same thing.
different. It's different.
It's just a
And
little
it's
bit better. It's a better form of hydrogen.
It is
Hydrogen was the
a
same.
Saturated, more
it's a
saturated
heavy
form.
gas. It's a heavy gas.
Still hydrogen, though, right?
No, it's not. It's not hydrogen and it's not oxygen.
The Brown's
And it
gas.
literally, yeah, it'll literally form in between your electrodes.
And this
if you
is
set
not
it up-
hydrogen? The
Correct.
Brown's gas?
If you set it up just right, your electrodes, you'll see all your oxygen bubbles on one plate, all your hydrogen bubbles on the other plate. If you set it up just right, right in between will be a column of gas bubbles just forming that's not connected
Right.
to either.
And that's the
not
Brown's
connected
gas.
to either. That's the Brown's gas.
And what do you think it is? Nitrogen?
No, it's not hydrogen. A lot of people
No,
put it in a brown.
Nitrogen.
No, it's not nitrogen.
I mean, that's in the
nitrogen
air.
is neutral.
I was
Nitrogen's neutral. It's not
I was
combustible.
just like HHO, but
Brown's gas implodes.
Influence.
well, so
Yeah,
does hydrogen
but-
and oxygen.
They explode. If you get your
No, they
ratio
implode.
perfect,
Could be heavy.
it'll
Could be
implode.
heavy hydrogen. No, there's that
No,
deuterium.
if you put that like, I mean, I remember my like sixth grade demonstration. You know, they had a glass upside down, was running it for a while. They went to light it, and it actually cracked the glass when it went in. But when they lit it, it turned back into water vapor. You know, it was compression wave.
If you get your mixture of
I
HHO
mean,
right, it'll implode.
Independently, hydrogen will explode, but with oxygen, it will implode.
But with that setup, you cannot get any closer to the heart of the magnetism. You've got your magnetism from the primary working its way inward, and then your secondaries. That magnetism goes into those ferrous rods, and then from there out to the secondaries, and they're directly wound to the graphite, not running all the way through, have a little spacer between it. You can't get any closer to the magnetic field than that. I think that would be the most efficient setup, and it would make it where it automatically self-spins.
Hey, can you post that link? I've never seen that. I've seen the end machine before, but always with the cover and stuff on it.
Some of the early experiments I was doing. So those are those magnets I was telling you about.
Oh, okay. I
Now,
see what you're doing now.
See the arcs coming off the disc?
That
the
blue up in the top
no,
right
no,
corner of it?
no, we're right where the brushes are, right where my mouse is, right here. Watch. See the sparks? See?
Mm-hmm.
The frame rate's too low on my end.
If you look closely, you'll see the arcs right here.
I see something, but it's hard to tell whether it's the brush or like arcing.
Yeah, it's
It's
arcing. It's arcing.
okay. It's really hard to see.
Yeah, it's the video's not the best.
Oh, okay. Okay. Now I see it.
Yeah,
It's like the end machine, you know, it's like the centrifugal force is playing a role in the switching. Because you don't have to be touching, you know, it's just the spinning seems to create the
Hey,
trigger.
you can get your RPMs exactly stable, right? Or
yes,
no?
yeah,
Try this. When your RPMs are perfectly stable, turn the base around and tilt it at different angles to see if you can find a particular alignment with the Earth's magnetic field to where you
yeah.
get an
That's true.
increase.
I never even thought of that.
Not just horizontal and vertical, but also,
Yeah,
That's what I
like
was
all
you
also.
know,
Yeah, because
360 times 360. See if
yeah,
you can see
gyroscopic.
if you
yeah, the Earth's field isn't just this
Oh,
way;
yeah,
it's also
probably the best
this
thing to
way.
do is put that thing on a gyroscope.
Yeah, and I
And
was able to light an LED because it only puts up very little voltage, but a lot of current. Technically speaking, at the voltage I had going through, that that LED wouldn't light up, but it did because of the current behind it. That's why it was able to light up. So it's only in
Maybe
microvolts.
hey,
one of
Microvolts
the
are you
magnet powder programs for your phone might help that.
posting this video online?
Oh yeah, it's been up there for 2 years.
No, I mean this particular recording right now. Are you leaving
Yeah.
it up?
Oh yeah, it's
All
been
right.
up there for 2 years.
Because I don't have really, I mean, I could have the time, but I procrastinate a lot, but I don't really have the space. I live in a semi. I don't
Yeah.
have, I've
So
got all the ideas, but I don't have the motivation. I don't know why. I can talk passionately about it, but when it comes down to actually doing it, I'm just like binge
yeah,
watching
I'm
Netflix or
hands on.
YouTube instead.
There's
But
another. I was actually hitting voltage. I was actually pumping a bit of voltage into it. I was getting a pretty cool arc going.
I would like if somebody was to build that design. Um, how your
Those magnets are
the
very powerful.
high frequency Ferris rods for the transformer coil with a Starship coil wound through its entire length, just one coil, and the wire exposed on each end connecting to a graphite pipe that doesn't meet all the way in the middle. The where they don't meet all the way in the middle, you want that gap to be a little bit bigger from how they're spaced this way. That way the electricity is promoted to go between the tops and the bottoms and not over through the gap. So
Yeah,
keep that in mind when you construct it.
yeah. I want to show you.
It'd be nice if you could move your banner over like an inch.
Mike, what happened? You didn't get that circuit or something?
You can't see him on the bottom.
Hold on a sec here. I just want to show you the end machine. I did the finished product.
If if that was to allow electrolysis without any electrolyte, absolutely pure distilled deionized water, that could change the health industry market. Because you could literally never have to clean it and drink the water straight out of the machine, which will have some structure to it, so it'll be
Well, I
beneficial
mean, if you get to
and
a
it'll be
high enough
saturated with
voltage, it doesn't
hydrogen.
matter. Yeah. If you get to a certain threshold of high voltage, keeping your current low, you're going to cut through that water, with
Yeah.
or without
And
a conductor.
high voltage and practically no amperage, your setup would generate less heat.
Right, because you get through the water without any problem.
Yep.
If the water can resist you, then the water will heat up.
Yep.
If you can break through the water, there's no resistance anymore. You broke through. You got to the other side. Where's the resistance? Where's the resistance? That's where the high voltage comes in.
I'd like to
You
see
don't.
that.
The amperage is not necessary to get to the other side of the. So I don't know if you guys, Anthony, you've heard of Ralph Ring, right? He's the guy with the ping pong ball in Time magazine.
Yep.
He's a naturalist. He worked for the military. The military was struggling to get an electron through a magnetic field. They were blowing transformers left and right with all kinds of high voltage, high amperage, trying to get the electron through the magnetic field. And Ralph Ring comes in there and says, let's just DC pulse, or let's pulse it. I don't know if it was DC, but he was pulsing. They were not pulsing before. They were just constantly pushing the current.
Well, they were actually trying to show it wasn't working, and they were mad at him when he actually did it.
Right. Yeah.
That's why
Right. That's right. Because they don't want the answers, I guess.
Yeah, he got it through instead of forcing it. He just did one at a time and let the electrons spiral through.
So there you go. Where's the heat? He got the electron through the magnetic field. The magnetic field was not able to resist the voltage because he was pulsing. There was a kickback, high voltage, reverse voltage. That's probably what got through the high voltage reverse polarity from the kickback of the pulse that he was using.
Hey, you replicated the Dunn Smith generator?
Yeah.
I would like to see
How'd
the
that go, Mike?
description that I explained actually work out to be the best setup. Keep it open source, and all these companies that are making HHO generators just switch over to it, so they're all equal to each other and using the best. And
Like Mike was
don't
saying,
need
he was getting better results with 48 volts and 24 volts. You know,
You gotta use
that's
high
because the voltage is higher. You got less.
The
There's less
resistance
that's
matters
out
less.
there that can resist you now.
I'm talking like 20,000 volts and practically no amperage at all.
Right.
Higher the voltage,
The
less.
higher the voltage
matters.
goes, the less there's less that's out there that can resist that force, which means the resistance is heat. When you rub your hands together and you push, that's the heat.
Well, as a ratio, the resistance matters less.
The kind of setup to where
That's why
you
we
could
run,
have.
like 110 kilovolts for the long distance power lines, or
I'm
more.
talking about
Yeah,
the
but all
kind of
forms of
setup.
resistance have a threshold that can be broken. Once you break that threshold, the resistance is gone.
You know how you can have a voltage jump several inches and make contact with you, and as long as it's not staying stationary, like long as it's constantly moving around, it won't hurt you.
Well, instead, it's very low current. That's what makes the big difference.
Right, there's
Yeah,
no
I'm
current
talking.
there.
I'm
There's
talking
no
about setting it up
just
like
voltage.
that. That way, if there was an issue and somebody got shocked by it, that it wouldn't
Okay, there's my
be
ambition
harmful
to
to them.
finished result.
Right, because it's all voltage, no current.
So I 3D printed the case. The magnets were inside that case. I used ceramic.
That's what
lining.
we have to learn how to use the high voltage and the no current devices to drive our equipment instead of mediocre voltage and higher currents.
With everything being semiconductors, that's really hard because the lower voltage, we've got our phones running at maybe, 1.3 or 1.8 volts for the electronics.
Hey, are y'all willing to discuss electromedicine?
But all that could be stepped
on
down.
here?
You could step down high voltage and all day long.
Yeah.
And step it back up. All day long.
Are y'all willing to
They're
discuss
already doing it.
Electromedicine? Are y'all willing to discuss that?
Yep, I already used that with my Adams motor. I put my transducers to my knees, and it takes the arthritic pain away. From
But it's heating up your ear with the cell phone is the amps, not the voltage.
But keep in mind, there are what I'm wanting to mention. Other videos of this particular electromedicine, when they're put up on YouTube, they don't stay too long. That's why I asked, because if I mention it, they
Yeah,
might be like, ah.
I never put up that stuff on my channel.
You drop the amps, the voltage goes up.
Just know you can set up electricity in a particular way across your arteries on the wrist. Not telling you how to do it, just the principle of it will
Bob Beck,
neutralize every single virus. Doesn't matter how bad or crazy it mutates, it'll neutralize all of them.
I tried the Bob Beck thing myself. Used a TINS unit instead on my wrist and ran it for a
Did you
couple
build
hours.
it or did you buy it?
I used a TINS unit.
You,
You
I don't
built
think
it.
that's the proper setup. It's got to be 3.93 hertz.
Well, I
20,
tried both a TINS unit and I tried running a DC to it 2 different
tw-
times. And then I also tried, I had some really big ceramic magnets. And I actually slept with it for like, I don't know, maybe 6 hours or so. Where I've got some pretty good, they're not like Neo power, but they're decently strong. And I had them on my wrists on both sides for a couple hours and didn't notice a big difference, but it seemed like it might have helped, but I'm not sure. Tell you something really that I noticed really did help is the colloidal silver.
Yep.
I had some sinus polyps, and I put that in like a spray bottle, like one of those nasal things, and it like made a huge difference. Even though my doctor
Oh,
said the only thing that would help is surgery.
uh, when you build an HHO generator, make sure your all the math and everything is done with your gas flow ratios to where at the torch tip you got 2 parts hydrogen, 1 part oxygen, the formula for water. Uh, if you have it exact, the torch tip will never heat up and water will come back out of the flame. For a short period of time, whatever you expose that water to, it'll manifest more of it.
Well,
So put in a,
you can't not have that ratio because you're breaking up water.
you can, I mean, it can not meet up. If you don't control the flow, you have little pockets of higher hydrogen concentration for a brief moment and vice versa.
Yeah,
But if you keep
yeah,
it
we just have 2 tubes coming out the top because that's a whole lot simpler. But yeah,
if you keep it steady and you get more, from what I've heard, what I understand, you get, if you keep the ratio perfect, you get 16 times more water out than what you started with.
I'd have to see that to believe it.
Did you see the video running of the end machine? I just had it going there. Showing the
I do know they use some of that for reducing radioactivity, though, which was interesting. On that,
Uh,
what was it? Brown. Oh, it was one of the Brown's gas demonstrations.
does it have any correlation with? Give me a second. I think it's John something.
Was that Yul Brown?
Uh,
Yull Brown?
I know of him.
John
There's a
Bedini?
certain
It's the guy that came up with Brown's gas.
water distillation. It cycles through hundreds of times, going back and forth between hot and cold in a certain manner, and exposing to UV. It structures the water a certain way, and that water has been said to neutralize radiation.
Well, radiation
Yeah.
is a natural absorber of radiation.
What's a natural
I'm sorry,
absorber?
water is a natural absorber of radiation.
Also, Stretch, another guy, it's on one of the Tesla Tech Talk channels. Vernon Roth. He described stretch molten glass out paper thin and coil it up to about the size of a shot glass with an opening in the center. When radiation hits that, it gets trapped until it just self decays.
It's all
Yeah, I heard
glass?
about that.
Hmm.
There's this device where it keeps bouncing around the radiation, just inside of it.
Any of y'all know of the Joe cell?
Yep.
I've heard of that. I tried that
Um,
once.
Yeah, he's in
and
Australia.
you know how the Joe cell is finicky?
Yeah, you can't
Yeah,
put
it
it
does,
near a railroad track.
the bubbles will jerk
You put
to
it
one
You can
near a
side.
have
railroad track, it'll die.
a working cell, and if somebody with a negative attitude comes around, the cell will stop working.
Yeah.
I I believe I know how to make a cell that'll make the same kind of energy, but it's actively powered, and that would avoid that finickiness.
I
Aluminum
think that
seems
finickiness is from
w-
the
that
Earth's
finicky
pulse.
that that finickiness is very likely from water having memory. That adds context to it.
I don't know. I think it's got to do with the full moon or something. Because I had a weird event on the full moon. The thing, the bubbles jumped to the other side when I was looking at it once. They were stuck on one side. I don't know if it was me looking at it that did that, but that night I remember it was a full moon.
Aluminum
And
doesn't work well with water long term, but the
aluminum?
aluminum has been reported to work better with the Joe cell. If you can find a metal like aluminum where protons attached to it, where it's attracting, have nested tubes of that metal with a small gap between each one, have all of the inside of the tubes, each tube, its inside surface area being super hydrophobic, have the ends rounded, curved, so there's no sharp edges, but the outside will have little sharp spikes since static energy likes to gather on points.
Mm.
The outside have it where it's super hydrophilic, water loving. Dunk it in water, leave it for a couple minutes, let it do its thing. Pick it up, drain off all the excess water. However thick a layer of water is sticking to it, have the spikes come up just flush with that edge.
It's like a
And then
microchannel.
from that from the edge of that water and the edge of the spikes, then you have an air gap. So the setup, you'll be performing the water bridge experiment. The very center pipe, you'll have a column of water. It's surrounded by everything super hydrophobic, so it is just floating there. And you've got your wires along with the installation plugged into it. That way, if the high voltage wanted to try to shortcut around and hit the metal, have the wires going into that column of water enough so the electricity is going to go this way instead of trying to shortcut, hit the metal, and come out. You won't see it, but it will be the exact same thing as the water bridge experiment. The water bridge experiment is held together by protons moving 10 times faster than the flow of the water. Water loving surfaces reorders the structure of water. So it's H3O2. It becomes net negatively charged.
Yeah.
And spikes like to gather the energy. So the effect will be you got your proton bridge in the center, an air gap, your metal, the water on the outside of the other, you know what I'm saying, the other side of that metal that is negatively charged. It probably won't share those negative charges with the metal, but it will be there kind of like a magnetic kind of attraction, energy just pulling to polar opposite charges. So it should promote the charges gather on the spikes and they're right there. They should jump that air gap if it's not too big. And then that next ring gets saturated and its energy gathers up on the spikes and jumps the gap. So from the radius out, take all the air gaps, add them up, and whatever voltage you want to work with, let's just say it's 20,000 volts, take your wires. Once that plasma arc forms, then you can bring it apart further. When that whatever that distance is breaks, you got to bring it in before it starts, bring it back out, and then it breaks. Whatever that distance is, and you take all them little gaps, add them up. Once you get close to that breaking distance where the plasma isn't supported, you're in the ballpark of being able, not quite there, but in the ballpark of touching the last ring and not getting the high voltage, but instead getting the protium. You'll need to add a significant number of rings after that, but with that, you could set that up directly on your engine block and it's actively powered, not passively powered. So that gets rid of the finickiness of the water.
Well, I don't know. I have to first figure out what protium is. I'm
I've
like
got a
way behind
feeling
you.
I've got a feeling that protium doesn't fully stay on that bridge. I've got a feeling that a good bit of it flies off.
What's protium?
The ion
Isn't
of
that's a
hydrogen.
metal of some kind, isn't it?
No, it is literally the ion of hydrogen.
The ion of hydrogen.
Protium will create a cold blue flame.
You know, aluminum is dense with hydrogen, right?
I think I knew that. I'm not sure.
Sounds like a hydrogen exchange going there, like a greater potential hydrogen to a lesser potential hydrogen from water to aluminum, because they're both hydrogen bearing elements. I mean, aluminum is you can extract, you can burn aluminum to get
With the way I
hydrogen.
just, all right, you know how the Joe cell, you leave it alone for 24 hours and you put a multimeter on it and it's supposed to show 1 volt for the Joe cell? So
My Joe Cell
being,
was getting a little bit more than that, actually. I think I was getting
but
3 or something.
this cell that I described could
Two,
also
2 or 3.
work, could probably work as a battery. It'll act as a natural capacitor because of the water loving surface creating those strong negative charges. So the effect is you got your column of water, the protons running up and down it. They jump that air gap, they hit the metal, go through the water, air gap, metal, water, air gap, metal, water, air gap, metal, water. It just keeps stacking out. It's
You're saying the
almost like a
Brown's gas there, layers there, between
it,
the
it, sh-
tubes.
it should
There's
it should
there's each layer of Brown's little mini layers of Brown's gas. You're saying.
not Brown's gas. You're not performing electrolysis on this. You're not
So what
splitting the
is Brown's
water.
gas? If it's not a hydrogen, what is it?
All right,
It's got. I mean,
just
it's got to be
look
something. You know, it can't just be the color
look
brown.
up
It's got to. What is it?
look up
You know,
look
it's
up
got to
the
be a
water
hydrogen of some kind.
look up the water bridge. The Joe cell has been described that the energy that it puts out is protium, which is the ion of hydrogen. The Joe cell water level stays the same. Um, when water loving surfaces, hydrophilic or super hydrophilic,
I mean,
reorders this,
you describe protium as an H, a single H. That's protium.
it's the electrical form of hydrogen.
Well, I mean, 2 H's is not
It's
protium.
way it's way smaller than the hydrogen atom. Way smaller. Extremely way
Oh.
smaller. I forget the measurements, but and it acts like static electricity. You can't
Just the
fill a balloon.
proton, no
You
no
can't
orbit.
you can't fill a balloon with it, you know?
So maybe that's what's going on with the Joe cell then, because it
Yeah,
seems to be a lot of hydrogen relations going on here between the aluminum as being a hydrogen material, the
but see
water is hydrogen,
the Joe cell is using
the steel is
non-magnetic stainless steel, and it works better with an aluminum engine block than cast iron.
right. I know that, and you have to have an aluminum
But the Joe
pipe
cell is
hitting the intake, touching the intake actually.
the Joe cell has been explained that the energy that's running the engine is protium, and what holds the water bridge together suspended in midair is protium. And I have a feeling the protium doesn't 100% stay inside that bridge. And the cell description that I just described, the inside surfaces of each pipe, smooth and super hydrophobic, repelling water, and the outside surface of each pipe being water loving with spikes the same height that the thickness of the water that it stays clean to. So the spikes will be flush with the water. And your repulsion distance from the superhydrophobic pushing against the water, you don't want your gap bigger than that. You probably want to take away like 5 or 10%. That way you've got that push like a strong magnet. You got water trying to be forced right up against it, and that would help support the water not drooping or sagging if you like go over potholes, etc. That way it all stay uniformly where it should be. That way if the layers shrink and you get regular water, it just wants to roll off.
Does that say keep a bigger gap then? Because the ones I've seen usually says it's near, like 1 millimeter gap at most.
I missed part of what you said.
I said, does that say to keep a bigger gap then for the browns than the HHO? Because I seen like the HHO and like trellises, like Stan Meyer, just to have as narrow gap as possible between the two electrodes.
You're talking about the setup that I explained just now for the protium generator or an HHO generator?
Oh, well, both. Is that not the same?
No, they're not the same.
Oh, okay. What about the HHO? I mean, the browns that you were talking about versus the HHO?
With the Brown's gas, based off of several factors, you need a particular spacing. If it's too close or if it's too far away, you won't get that third layer of bubbles between the electrodes.
Okay.
And I'm echoing.
Don't hear an echo here. Maybe you got the YouTube still going.
No, I closed it. The Brown's gas doesn't want to break the surface that well, so disturbing the water helps release the Brown's gas that's trapped in the water.
You put an ultrasound transducer in there.
Yeah, that'd work.
Yeah. I've got one of those cleaners, and you can fill it up with hot water, and you can't see a thing. You turn on the ultrasound, and it's like makes it crystal clear in like 3 seconds.
Yeah.
First time I see that, I was like, "Whoa, that's pretty cool." Didn't know it was going to do that. It's like completely removes all the air really quick, so must remove all the gas pretty quick.
But your gap between the protium generator, you're going to want it smaller than the repulsion distance from the water. And you're going to want it small anyway. That way it's more promoted to jump the tips of the spikes going into the next layer. And once you have enough gaps from the radius out, not the diameter, but from the radius, the center out, additive, all them gaps being significantly larger than the breaking point of the high voltage plasma, you should be approaching where it's safer to touch, and you won't be putting the high voltage directly on the engine. It would be getting the protium.
See that working?
What about working?
Oh, I said I'd like to see that working sometime.
Yes. I need a CNC machine to make that.
No, you can kind of come close for the plates, like some of the air cleaners, the electrostatic air cleaners.
Platinum.
You know what I'm talking about? They already have the plates in them.
Yeah.
All you'd have to do is like remove the side that connects them all together. Then, you've already got your fixed distance.
These would be rings that are nested inside of each other for the protium. But
Never-
if your alternator could put out enough power to convert it all into high voltage, practically no amperage, and keep that cell running, you'd literally never have to shut your engine off.
Guys, we're gonna wrap it up here in about 15 minutes. So if you guys have anything you want to close up on,
Yeah, I'm getting too tired myself. I keep yawning for some reason.
yeah. Well, we've been going almost 2 hours, hour
Have we?
45 minutes.
Oh, man.
So, yeah. Yeah.
And I get
If
much
you've got-
sleep. I'm messed up.
If you've got something revolutionary, world changing, forget patents and
Yeah.
plaster it all over the internet everywhere as fast as possible.
I like the Thane Hines idea and combine that with like Flynn to where they're doing flux switching. Because if you're not familiar with Thane Hines, he's making the bitoroid transformer. To basically where it diverts the back EMF. And if you have it on an oscilloscope, normally a loaded versus an unloaded transformer, it changes the. Or do you have electronics background?
No.
Okay, well, but it changes the timing of when it draws current, when it doesn't. But basically, the way he has it, it doesn't, even though it should, you would think. But they're like a little bit out of phase, out of time, so you end up with like almost no total power.
Y'all think I described my HHO cell setup idea good enough?
Yeah, I know with the smoothness on one side and
No, that's the protium for HHO, hydrogen and oxygen.
the cell I
The
made,
the Starship coil primary with a lot of secondary Starship coils in the center of the primary. Your high
with the
frequency,
points of the secondaries touching the
Your-
circle of the primary.
hold on one second. Let me.
The star, right?
Can I switch my camera on this?
yeah, you can switch it to front and back.
Is everybody
Oh,
using their
see.
cell phone cameras?
That's interesting.
Yeah, well,
I
I'm
don't
running
see
this
how.
server on.
You know what? AI. I just thought of a good use for AI robots to wind
Mine's
these
like really
coils.
washed out. I'm using the
All these
webcam.
crazy coil designs we want to do. You know, that's a lot of hard stuff to make.
So here's a bucket, and let's just say it's full with water. So on the outside of this bucket will be a big Starship coil. That'll be the primary on the outside, and on the inside you've got a bunch of your ferrous rods that would be used for the core of the transformer, but they're all spaced out hexagonally, and then around each rod you've got a tiny little Starship coil going around each one independently.
Oh, okay.
And you set the ratio up so where these are all
Yeah.
voltage,
Now it
no
makes sense.
amperage. Each one of
That's
these
like a Tesla
inde-
transformer or a Tesla.
It-
It sounds like the other guy's design, that the one that has the rotating cylinders around it. I can't think of what he's called it, but
primary,
it's
secondary, with multiple secondaries.
so
the guy
multiple.
any
all-
gravity from it.
This will be stacked with secondaries. All the secondaries are identical, and the power that you're putting into your primary outside the bucket and all of your secondaries that are inside, just wire it. It's different math than a regular coil, but just
Well,
wire it all up
hey,
to
David.
where these are all high voltage, and then once you've got your rod and your Starship coil wound up the entire length of that rod, and a graphite sleeve that'll go just around the tips of that rod, and then pour that with resin. And if you could put like a little bit of a concave or a bump for the surface, and then your like a wooden plate or whatever plastic plate going over top of it, have the concurve match it, but the arc be a little bit different. So just say you've got your your rod,
Gosh, a
and
drawing
then
would
you
just
gotta
be so ideal.
you gotta
Like a
here.
drawing.
Hold on. Here we go. Just say
I see what you're
so.
saying.
So here
Why
it.
you got the carbon over the ferrite?
So
Graphite. You had the graphite over
mm,
the ferrite rods on the top. I heard you say that. Putting
hold
graphite
on.
on top of the ferrite rod. What does that
So
do?
so if I don't even know what I'm showing here.
Is that
So this would
for the reception to the secondaries? The graphite?
so this is your rod that would be used for a core of a transformer, preferably high frequency. It
Iron?
does not retain a magnetic field. You take the electricity and the magnet away, there is zero magnetism on it. So it's good for alternating polarity back and forth very quick. And then
Move
all
That's
these
what the
your
little
carbon
camera down
line,
like
steel
an
would
inch.
do.
Move your
all these
camera down an
line,
inch so you can see better.
Low carbon steel.
There.
yeah,
Okay,
I
yeah,
think
that's
that's
better.
it.
Oh, it
And
was.
all these lines running across it would be representative of stacking up a starship coil. And then the points on the starship coil
Okay.
will perfectly the diameter of
Can't see
whatever.
what you're drawing, dude. I can't see what you're drawing at all.
Yeah, you need to
Face
move your camera down some.
I can't. How do I flip my camera around? I don't
You,
see
there's like
how to do it.
yeah.
Click on settings and then
That's the learning curve I haven't gotten to yet.
Settings,
I'm not
camera.
good at cell
Okay,
phone. It's like the
I see
webcam
it.
is quality's
It's
low.
like a little
the
circular
cam,
arrow
yeah.
or something.
I see it. I think.
We can do it without the battery running out.
Here we go. Boy, now it's all out of focus. So
That's good.
there, it's hard for me to see what I'm looking at. I gotta hold on. Let me zoom my screen in so I can. So this would be the high frequency rod that would be used for a core of a transformer, and then you stack your starship coil to where the inner hole of the starship coil perfectly matches the diameter of that rod, and then
Right.
the tips of the starship coil, whatever diameter of a circle they would perfectly nest against, you take a graphite rod, hollow it out, or if you can get a graphite pipe, and that will
Right.
nest down over it, perfectly nesting against the tips of the wire. And then you pour resin in here. And if you could make your resin
And your
kind
primary
of,
goes over that?
yeah, this will be your secondary.
Secondary.
Many of them stack together. And if your resin, you can have like a little bubble across the top, and whatever plate that holds these will have a little bit of a bump or a bead that'll
Gotcha.
nest into that, so it'll have the least contact surface area, and it'll hold it in place. It won't be able to wiggle around. And then do that for the bottom. But your graphite rod here, what you see right here, mirror this, and you won't have graphite all the way. You'll have a ring of plastic or glass that this is like a ring, coming up out of the page back into the page, a ring
Insulate
around
it.
it, and then you continue your graphite rod. I'm looking at my camera while I'm drawing in the frame where it's lagging. So this rod goes one solid rod all the way through, and one fully stacked starship coil all the way through. And this starship coil is making direct contact to that graphite on the inside, and the end of this starship coil is making direct electrical contact to the inside here while it's filled with resin. And, and this gap here needs to be, I'm echoing, needs to be a little bit bigger
Sorry, that's me.
than the spacing of however far you're going to put them apart. So that would mean this coil in one cycle of the pulse wave, it's positive up here, and the other one's negative down here, and you orient the coil winding the opposite for this other one. So when this one's positive, that one's negative, and the next one's positive, and the next one's negative, just kind of hexagonally stacked. Like you can.
You know that the Tesla
6.
coil, the primary is receiving AC, right? Whatever.
Hey, is my
But,
audio still?
So you
the
just keep
secondary
this.
is receiving the flyback.
So this will be the top view of these. This will be the top-down view of these. So the spacing here, you want that smaller than the spacing here. And you could just wire, instead of doing a positive in the center, and then that ring being negative, and the next ring be positive, and then the next ring being negative. Instead of stacking them that way, you could stack them that way, to where all them top halves will be the same polarity, all of them will be the same polarity, but opposites of each other. See what I'm saying? You can stack them up that way, wire it that way, instead of rings. You know what I mean? But that's the top-down view of these. And with that support, it'd be a sphere sitting on a flat surface or any other surface gives the least contact point. So that little angle right there, just have it really a shallow curve, and the plate that has like a half a bead or something nested into it to sandwich them all at the distance you want. And
Okay,
with your primary out here, higher amperage or however you're going to have it set up, you want it to where these they get their power.
It reminds me of the Searle setup.
It's been a very
these
long time
devices
since I
are
looked at
just
Searle.
taking the flyback, the high voltage kick.
Yep. So
Okay.
you've got your bigger primary outside the bucket. Its magnetism will magnetize this, and that magnetism will go from that coil. So you can't get any closer to the heart of a magnet. Like here's where all your HHO bubbles would be coming up at. You know what I mean? There's where all of your gas bubbles would be coming up at.
You
I
can make
always
it a
thought it'd be great to
linear
just to power a HHO generator with flyback voltage. With a flyback
instead
driver.
of making a circular winding, make it a linear winding. In other words,
Say again?
instead of making a circular winding, make it a linear winding. Instead of going okay. Let's say this is like
a
instead
starship
of it being
coil.
like this, instead of being like this, have the windings this direction around
I gotta
here.
zoom my camera back out. Say that again. I'm looking at your camera now.
And instead of let's say like this is the core, okay. Instead of having it like that normally with like the starship coils,
it's not that way. A starship coil is nothing but straight lines.
But I'm saying just for a different setup for this part of it. Instead of having it going around in a circle, having it go linearly along the line of the shaft if you want to make it several stacks.
I know you can make a transformer. I know you can make a transformer out of.
It would be like a toroid, but it would be a toroid that instead of is a okay, kind of like how we have these flat transformers, whereas the old toroid transformers were basically like a ratio about like this, and they had the windings around them like this all the way around.
Yeah.
Now we have them where they're maybe an eighth of that, and they're more flattened out and more the core's more width spaced. Instead, you could do the opposite, both directions. You could go if you wanted a long core, you could make them long and tall, or you could go the other direction, and you might get different effects from it.
But what I was getting at, you're plugging the
So
wall source.
put the other cores in there.
You're plugging the wall source of electricity would be outside of where your water is, but it's still all one transformer. You're taking that power and then bringing it to all them little points here. So you won't have any direct wires touching electrodes that are going into the water. Uh, it'll be completely coated in resin. So you get what I'm saying?
What are you talking about? Inducing the
Yeah,
voltage in the water?
the only thing that is electrically conductive that will be touching the water will be the graphite. You won't have the wire coming into the water touching the graphite and having to worry about putting something like putty or something around that. But even if you did that, then you wouldn't benefit from the spinning flinging off the bubbles. But this way, the electricity is being generated from the inside out to the electrode surface area. It'd be a safer setup. You wouldn't have to worry about,
From
what I'm
the
saying,
inside of the
not
graphite ring. From
you
the
wouldn't have to
inside of
worry
the
about
graphite ring.
You're
not
just making
good
an isolation
electrical
core out of it.
From the inside of the graphite ring
is where the
is
power is
your
being
is
generated.
where your Brown's gases, whatever happening.
No, that's where the Starship coil is generating power.
Right, but
Guys,
the
guys,
graphite ring
we're gonna
inside of the
square it
graphite
up
ring.
here in a couple of minutes, so just get your final stuff in for the night. And I just want to make a few announcements before we end the live stream tonight. So, yeah.
All
Anybody
right.
want to close up with final thoughts?
But with that setup, any heat that's generated goes into the water, and warmer water is easier to split. And doesn't matter how
Right.
you build a cell, if you bring a magnet up to the plates, you're going to get an efficiency increase. With this setup, your electrode surface is literally in the heart of the magnetic field. Your any magnetic field that is wasted is
Right.
benefiting into that phenomenon that makes it draw more amperage. So you're piggybacking off the magnetics that are already there. You can't get any closer to the magnetic field, and a magnetic field gives you that much more enhancement.
Well consolidated, David.
Yeah,
Yep.
really cool.
That
Well,
explained it all right there.
I think we're
And the
gonna.
Starship
I
coil
mean, I was
versus
just
the
about to say, why not just put the graphite in there and have your transformer on the outside of the water altogether?
but
You just answered that question.
because then you got to bring wires coming in. You see what I'm saying?
Yeah, no, you just answered that question. Your magnetic field is right there at the graphite. It's there. It's
I,
not
I had
outside
an
of the
an
water.
I had an idea before this one, but it wasn't as advanced. This one's a little bit more
That's
advanced.
interesting.
Before I was thinking you would need a bearing up at the top and a bearing at the bottom, and you pass electricity in through the bearing. This eliminates the need for bearings.
The coil will naturally heat up. The water will cool it down, or whatever, transmit the heat to the water. But the
Yep.
magnetic field
Also,
is localized right there at the graphite.
right there,
Yeah.
exactly. It's you're literally in the heart of the magnetic field where you're doing the electrolysis. It's
Mhm.
perfect marriage of setup.
Cool. Well, I think we're
Right.
gonna
Whereas
call it
before,
quits,
these HHO
guys.
generators were just had the graphite rod in the water.
Yeah, it's just a
You
bunch
know.
of rods or pipes, and you're bringing your wires in, and you know, with this setup, it might make it to where you can split water without any electrolyte. Might
Yeah. So
or extremely little.
You treat it as a capacitor, baby, like Stan Meyer did. Basically, made it like a lossy capacitor, and didn't use an electrolyte.
guys, I hate to cut this off. I do have to close the stream for tonight. I gotta be up pretty early in the morning. So,
Yep.
again, thanks a lot, everybody, for joining us. I'm going to be doing a stream probably after Christmas. So next Friday, I won't be doing a show because obviously it's the weekend of Christmas. And I'd like to wish everybody happy holidays
Man,
if you
Christmas
celebrate
that close.
Christmas. And yeah, it's right around the corner. It's creeping up on us. So again, thanks a lot for joining us. Any questions, comments? You can go to Faraday Research on YouTube. I got tons of videos there. You can check out what I've been working on for the last couple of years. Faraday disc, Adams motor, Don Smith device, whole whack of stuff. So yeah, do your research.
Did you say you had a website too?
No, I don't have a website. I have a Facebook channel, and I'm on Instagram. I have the YouTube channel. I'm on Odyssey. I'm also on Rumble. So I'm spread out. I have my stuff out there everywhere. So yeah, that's the key to it is try to branch out as much as possible. So who knows when YouTube's gonna say, okay, Faraday Research, you're going bye bye.
How much power did you get out of your Don Smith setup?
Don Smith, I had mine up to 11 kVA. So yeah, it was honking pretty good power. So
What was you powering?
I was just powering a dead load. I was powering lights. I hooked it up to a big toroid transformer. I kind of got away from it because I was worried about the radiation part of it. When you're getting up that high in the radiation, the high voltage
Right.
like that, I was kind of worried about the health effects of that. So, yeah, I was just dabbling in a whole bunch of different areas, and
Yeah, you start getting around the 30s, you're making X-rays, 30s and 40s,
yeah. So, and
maybe the
at the
20s.
time, yeah, I had vacuum spark gaps, and I had that going on too. So I was kind of worried about the radiation levels. So, yeah. But anyways, guys, thanks a lot for joining us. This live stream will be posted under the live tab at Faraday Research. So if you missed half the show or you missed a certain part of it, you can go back and watch it. And yeah, so everybody have a great holiday, and we'll see everybody soon.
Yep.
Happy
Everybody take care.
holidays, guys.
Take care.
Bye.
Okay, I'm offline.